Hi, for this video we are going to familiarize ourselves with some properties of exponents. And as we work through the properties of the exponents, we're just going to do a few examples just to demonstrate the property. The first property that we're going to look at is called the zero power. Now the zero power is any base to the zero exponent. So any base, in this case it's base base b to the zero exponent. The rule is any base to the zero is 1. And sometimes that's hard for students to remember because when we see a 0, we automatically assume we're multiplying and we're going to get a 0. Or b to the nothing is really just giving me a b back. But the truth is any base, there's my example, base 3 to the 0 is 1. Base negative 12 to the 0 is still 1. I could have pi 3.14159 goes on forever to the 0th power. My answer is still 1. Keep in mind sometimes you're going to have parentheses around numbers, but if you have something like negative 7, actually it's negative 7 to the 0, that's the same as order of operations first. You do your exponents first. 7 to the 0 is a 1. Make it negative, and you end up with a negative 1. The second property we're going to look at is the negative exponent property. What do you do if you end up with a negative exponent? A negative exponent is basically the same as the reciprocal. Basically, anytime you see a negative exponent, the rule is that if it's in the numerator, it's going to go down to the denominator and it's going to become positive. The exponent will become positive. In this case, I have b to the negative n in the denominator, which means move me, flip me, and put me in the numerator. My final answer will be a b to the n, positive n, and it will be in the numerator. So let's look at a few examples. Here I have a to the negative 4. This is the same as a to the negative 4 over 1. A negative exponent says move me, flip me, put me in the denominator. So my answer here, my 1 will go upstairs, and I will have an a to the 4th power. Notice once I move my base to the numerator or the denominator, my exponent becomes positive. Okay, let's look at this one. I have 1 divided by 3 to the negative 3. In this example, I have the negative exponent in the denominator. So again, it's shouting, move me, I'm a negative exponent. So he's now going to say, all right, I don't want to be in the denominator, put me in the numerator. So once I'm in the numerator, my exponent becomes positive. 3 to the 3rd power is a positive 27. In this example here, I have a negative 4 to the negative 3, and it's in the numerator. So he's upstairs. Negative 4 to the negative 3. In the denominator, I have a negative 2 to the 5th power, and it's negative as well. So we're going to have two bases switching places. My negative 4 base is going to flip to the bottom. My negative 2 base is going to flip to the top. So here is my fraction. In the denominator, I have a negative 4, and it is to the positive 3. Remember, once I am flipped, once I am moved, the exponent becomes positive. The negative 2 moves to the numerator, and he keeps his exponent of a 5, but it's no longer negative. So let's multiply these numbers out. A negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is a negative 32 in the numerator. Downstairs, a negative 4 to the 3rd power is a negative 64. My negatives are going to cancel out, and I will be left with a positive 1/2. So again, just a reminder, when you see a negative exponent here, you do not change your answer to negative. It has nothing to do with whether the answer is positive or negative. What it does is it tells you whether you're moving it to the numerator or the denominator. It has to do with flipping the fraction. Okay, let's have a look at the product rule. The product rule tells us that if we multiply same bases, let me put this back. If we are multiplying same bases, here I have same bases. The rule is that you will add your exponents. So here I just have it in terms of b, just like above there. So I have b to the power of m, and it's timesing another b, same base, to the power of n. The rule is you keep the same base, but you now are adding your exponents. So here's an example. I have a to the third, a squared, and a. One thing to note is if you have an a or a b or a variable of any kind all by itself, put a little 1 to hold the place of the exponent. Sometimes we get confused and we want to put a 0 up there because we don't have anything up there, but it's an imaginary 1. So the rule is when I'm multiplying these same bases, I add the exponents. So I keep my a because it's base a, and then I'm multiplying. When I multiply my bases, I will add my exponents, 3 plus 2 plus 1. So my final answer is a to the 6. For this example here, I have not just x's and y's, but I have numbers out front as well. So here I have a negative 2 and a negative 3. So I'm just going to put my numbers together out front here. We're going to just group them. Then I'm going to look at my x's, okay? So here I have an x to the 3. Here I have an x to the, oh, there's nothing there, so it's a 1. And here I have an x squared. So let's put all of our x's together. I have an x, and I'm multiplying them, x cubed times x to the first times x squared. The rule is I can add the exponents. So I have a 3 plus a 1 plus a 2. Now for my y's, here I have y to the first power. Here I have a y to the fifth, and here I have a y to the second. When I multiply these same bases, the rule is I can add the exponents. And that's why I end up over here with a y to the 1 plus 5 plus 2. So when I simplify these out, I have a negative 2 times a negative 3. That gives me a positive 6. And I have an x to the 6th power when I add up all my x exponents, and I have a y to the 8th power when I add up all my y exponents. Looking at the next rule, it's called the quotient rule. It's very similar to the product rule, but instead of multiplying, I am dividing. So here I have the same base of b dividing by the same base of b. The rule is, instead of adding my exponents, I will subtract them. So I take the top exponent and I subtract the bottom exponent. And in this example here, I have an a to the 7th divided by a to the 2nd, so I can subtract that too. And then I have b's. I have a b to the 3rd, take away b to the 7th. Okay, so let's have a look at this final answer here. A to the 7 take away 2 is the same as a to the 5. And b to the 3 take away 7 is b to the negative 4. Remember, from our negative exponents, a negative 4 attached to a base is saying, move me, move me, move me. So he's going to want to go downstairs into the denominator. I have an a to the 5th divided by b to the 4th. Remember, when I put him downstairs, he becomes positive. The negative exponent becomes positive. one way that is easy when you're dealing with division of same bases is looking at who wins, the top or the bottom. In this case, my top wins, and he wins by 5. So I write a to the 5th in the numerator. For my base b's, it looks like the bottom wins, and he wins by 4, which is why I have b to the 4th in my denominator. The last rule that we're going to have a look at is called the power rule. Now, the power rule is what we look at when we are when we have a power to an exponent. So here I have a power with an exponent, and that exponent with the base is being taken to a power. The rule is, and I have a power to an exponent, I multiply my exponents together. So let's have an example. Let's look at an example of that. So here, this is the same as saying I have 4 packages of u squared v cubed. So I have u squared v cubed, u squared v cubed, u squared v cubed, u squared v cubed. And instead of writing all of that out, what I can do is I can say, okay, I'm going to multiply this exponent by the u squared. I'm going to multiply this exponent to the 3, the cube on the v. So my work would look like this. U to the 2 times 4, v to the 3 times 4, and my final answer here will be u to the 8th times v to the 12th. Okay, so let's look at this example when I have numbers like a 6 and a 5 in front, and when I have a division bar. So let's have a look at this one here. Okay, the rule is, again, this exponent is applied to every base. The 6 is a base. Remember, he has an imaginary 1 up there. The 5 is a base. He has an imaginary 1 up there. So the 2... let's do the numerator first. The 2 is applied and multiplied to the 6 to the 1. So I have a 1 times 2, which is squared. I have an x to the 3 times 2. 3 times 2 is 6. Then we do the same thing with the denominator. I have that one covers that up. Let's get rid of that. I have a squared that is going to go to the first power of the 5, and I have the 2, the squared, which is going to go to the y squared there. So I have a 5 to the second power, y to the 2 times 2, which is 4. So when I multiply these, when I use the exponent, 6 squared is 36, and I have an x to the 6th power, because I multiplied exponent to the exponent. We multiply. 5 to the 2nd power is a 25. And again, y to the 2nd power to the 2nd power. We multiply those guys and we get y to the 4th power.